Hi guys. If you're watching this video, then you're probably quarantined. Definitely miss you from class, but just want to keep you up to date with what we've been working on. So we worked on this the week of January 19th through the 22nd. So Tuesday, Wednesday, Thursday, Friday. So you may have been in class for part of those days or some of those days. So just this is a recap of that stuff. So function transformations. Also inside the folder where you found this video are any of the papers that I'm going to show you. And then I have a worksheet for you guys to work on and turn into me to count as your work during this week. All right, so first, excuse me. All right, so these are just going back over different function transformations. So a function transformation is when you're changing a function, whether you're sliding it to the right, to the left, moving it up, down, and then you can reflect it over the x-axis or reflect over the y-axis. Or what we're going to talk more specifically today is the stretching and shrinking and like what that does. Okay, so we took these notes in class. You had a paper that looked like this, and we talked about all the different things that happen. If you are not here for that part of it, then you may want to pause this video and write down these notes and have them. So when you add something outside of the parent function, so your parent function could be x squared, it could be the absolute value of x, square root of x, it could be any of those types of functions. So we have our parent function, then we add something on the end of it, that's going to move that graph up. So for example, if we have x to the third, that's my parent function, plus 7. That means I'm going to move this graph up 7 units. When you subtract, it moves it down. Okay. Now, what's different about the first two and the second two is that notice that the adding and subtracting happens outside the function. Here it's happening inside the function. So when you add inside, it's opposite of what you would think, because you would think if you add, you go to the right, but in this case, you actually move to the left. So here's an example. So you have x plus 2, so you're adding, so this moves it to the left, and then the square's on the outside. So we're doing the adding to first, then we finish out the parent function. Okay, and then the same thing here. When you subtract, you're going to move to the right. Okay, and then we have reflections. So reflections come into play when you have negatives. So if your negative is out in front of your function, so for example, negative parentheses x squared, or it could look like this. That means we would do the x squared first, then put the negative sign on it. That will reflect it over the x-axis. So that's going to reflect it from the top down to the bottom. And then if the negative sign is inside the parent function, so like here, this is inside the absolute value, so that's inside the parent function, that's going to reflect over the y-axis. So that's going to flip you from right to left, back and forth, okay? All right, so then today we're going to talk about what happens when we multiply outside the function and then inside the function, okay? And then this is talking about when a is bigger than 1. And this is talking about when a is a fraction, like 1/4, 1/2, 2/3, 3/6, whatever it may be, okay? But no negatives, because the reflection takes care of our negatives, so we don't have to worry about that. So we're just looking at whether it's a fraction or if it's a whole number, okay? All right, so looking at this paper here, this gives some really great pictures and descriptions, okay? So on here, this color is the original function. So when I highlighted them down here, the dotted line is the original function. If you notice, it's the same function every single time. Okay, it doesn't change, doesn't move. Then we do something to it. So here, we're multiplying outside of the parent function. So this would look something like, for example, so this is probably x cubed. So this would look like 2x cubed. So we would do the x cubed first, get an answer, then multiply by 2. So the 2 is outside of the parent function. And notice, so what happens is it's a vertical stretch. So basically we're taking this and we're vertically stretching this out. So what happens is the new graph looks taller, okay? Here, we're multiplying by a fraction. So this would be something like 1/3 x to the third. Okay, so again, we would do x to the third first, then multiply it by 1/3. So when we multiply it by 1/3, we're actually going to, it's called a vertical shrink. So we're actually taking this function and we're pushing it in. So if you notice, this orange is smaller or shorter, right, in these areas than the original graph, okay? And then we get into when we're multiplying inside the function, okay? So this would be something like this. So 2x cubed, all of that together, okay? Excuse me. Oh, I'm sorry, I put the parentheses in the wrong spot, right there. There we go. So we have 2x and then raised to the third. So we're multiplying the 2 times x first, then raising it to the third. Whereas over here, we did x to the third first, then multiplied by 2. So 2 different things. So now this is horizontal, okay? Now, this is a little backwards from what you would think, because over here, when we did a whole number, we were stretching. But here, when it's inside the parentheses, it's actually going to be shrinking. Okay, so this is a horizontal shrink. So we're taking our function and we're pushing it in. So we're shrinking it in. So this gets thinner. So notice the orange here is thinner than our original function. It's more pushed in towards that y-axis. And then here, excuse me, we're multiplying by 1/2. So again, this would be something like 1/3 x, and then all of that raised to the third power. Okay, so now if you can see, we're taking this and we're stretching it horizontally. So we're pulling it out. So we're stretching it this way. So when that happens, our graph gets wider. So you can see the orange is wider than our original one. Okay, now we also have to say by what scale factor that these are being horizontally or vertically stretched or shrunk. Okay, so when we're looking here, this would be by a scale factor of 2. This would be by a scale factor of 1/2 because those are the numbers that are there, okay? Down here, this would be a scale factor of 2. This would be a scale factor of 1/3. Now, it's a little different when it's inside the parentheses. You have to take the reciprocal, okay? So this right up here would be by a scale factor of 1/2 because remember, if we have 2, the reciprocal over that is when you flip your fraction. So this would be 1/2. So this would be horizontally shrunk by a scale factor of 1/2. Here, this would be horizontally stretched by a scale factor of 2 because again, you have to flip the fraction. So that's the hardest part, is remembering that that's the reciprocal, okay? All right, if you have this paper, go ahead and grab it out. Make sure you have it, and we'll fill in the rest of this. You can pause the video and find it. And then if you don't have this paper, then I would be writing this down in my notebook, or you can print it off. I have it in the folder. Okay, so we're gonna say that for A is the number that we're using to multiply, and then f of x is just whatever parent function we have. So this is when A is greater than 1. So this would be a vertical stretch by a factor of A, whatever that number is, okay? So for example, we can say we have f of x equals 4 and then x squared, okay? So we would say that this graph is being vertically stretched by a factor of, and since our number is 4, we would say 4, okay? Now, when it's between 0 and 1, so it's that fraction, this is going to be a vertical shrink by a factor of A, so whatever that number is. So again, here's an example. So we have this. It could be 1/3, and that's times the square root of x. Okay, so this is our parent function, and then we're multiplying it by 1/3. Okay, so we would say that this graph is being vertically shrunk by a factor of 1/3. Okay, that's how we would list that transformation. Okay, and I'm going to show you how we list those transformations here in a second. We'll do that. All right, so now we're going to switch, and now we're looking at, we're multiplying inside of the function. So we're going to multiply first, then do whatever the parent function tells us to do. So on this one, this is going to be a horizontal shrink by a factor of 1 over A. So this, remember we said, is the reciprocal, Okay, so you flip that fraction or flip that whole number. Okay, so for example, if we had f of x equals, let's do it like this. So we would multiply this first, then do the squared. And x squared is my parent function here. So I'm multiplying by 4 first and then finishing the parent function. So we would say this is a horizontal shrink by a factor of 1/4. Okay, horizontally shrink by a factor of 1/4 because we take the reciprocal of that. And then finally, the last one is when a is between 0 and 1, so we have a fraction. So this is horizontal stretch by a factor of 1/a. Again, you're flipping it, reciprocal, okay? So if we have f of x equals 1/5 x squared. So again, we're multiplying by 1/5 first, and then we're squaring it and finishing the parent function. So we would say that this function is being horizontally stretched by a factor of, instead of 1/5, we would flip that and say by a factor of 5. Okay, so these two here, you got to remember your factor is going by the factor, right? When we say by the factor, it would be the reciprocal. Okay, so it's always the reciprocal, so you flip that upside down. So if you have a whole number, it turns to a fraction. If you have a fraction, it turns to a whole number. All right, and that's what the top of this paper shows here, right in this section. That's just another way to write it and to see it, okay? All right, so let's look at a couple examples. Let's talk about how we would figure this out. All right, so if I have this first one, so what are all the transformations happening here? And then how would I write that out? Okay, so grab a marker here. Okay, so I'm gonna start here. I see there's a squared, right? So that means that x squared is my parent function. So everything else on here is going to be a transformation of some kind. All right, so if I look at this, let's see this negative sign. So this right here, right? That is going to tell me, if I'm looking at my paper, so a negative outside of the function is going to be a reflect over the x-axis. So reflect over x-axis, okay? So that's what the negative sign up here does. It reflects it over the x-axis. All right, x is just x, nothing there. So then we have a +3. So +3 inside of the function. So that's going to be right here. So we're adding 3 inside of the function. That tells me I'm going to move left. So I would say left, and this many units, 3 units. Okay, so this +3 right here, all that is this left 3 units. Okay. Sorry, I'm just trying to highlight that and make it easy to see. I'm not scratching it out. All right, and then finally we have this +4. So +4 on the end is going to tell us that we move up. So this is going to go up 4 units. Okay, so this right here tells us to move up 4 units. Okay, pretty simple, right? I mean, you're just taking each one, you're looking at what's changed from the parent function and then talking about what transformations that is. All right, let's jump down to this one right here, okay? So we're gonna start with our negative. It's outside, so I see absolute value, so my parent function is f of x equals the absolute value of x, okay? So, excuse me, this is my parent function, so everything else is gonna be some sort of transformation. So let's start with the negative. So that's gonna be reflect over x-axis, okay? So this right here is reflect over x-axis. All right, then we have the 2. All right. Okay, so now the 2, that's going to tell me now that's outside of the function. We're multiplying outside of the function, and my a value is bigger than 1 because 2 is bigger than 1. So this is what it is. It is a vertical stretch by a factor of 2, okay? So when it's outside, it's exactly whatever number that is, okay? So that goes with blue. That's where I got that. All right, Then we have this -3 right here. Okay, that is going to tell me that we are moving right 3 units. Okay, and then our last one here on the end, we have this +7. Okay, so we have that +7, so that's going to tell us up 7 units. All right. Okay, so that's what all of those things mean. So as you work on these, they're going to get easier and easier. So you have a worksheet that you're going to work on. I had it right here. Here we go. All right, so you either can print this off and write on it, or you can just write on it on your own notebook paper. It's not a big deal, okay? So you're going to take this and you're going to list all of the transformations that are happening. So I want you to make sure that you have this paper with you and you're looking at what's happening and knowing what it's going to do, okay? So if we did this first one together, I have a 2 out front. I'm multiplying. So when I'm multiplying out front by 2, right, it's this right here, because my A is bigger than 1. So we would say on that one, we have a vertical stretch by a factor of 2, okay? All right, and then we have a -3 here. So the -3, it's inside the function. So here it is right here, minus, so that means I'm moving right. So right 3 units. Okay, and then our last thing here is a +1, and that's right here. We're adding, so we're moving up. So that would be up 1 unit. Okay, all right, so I want you to work on this. You will take a picture of it and you will submit it to me. You see in the folder, there's a spot for you to submit that assignment, so make sure you do that. And then we'll talk about the next, I'll send another video with the next set of instructions and what you are working on. All right. If you have any questions, please don't hesitate to reach out to me at all. Please, 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 please. My planning period every single day is 4th period. So from 10:47 to, we'll just say 12:15. Excuse me. 10:47 to 12:15, I'm available, so I can always video call you. We can do a Teams call at that time, and I can explain things that way. Or if you just have questions, you can send me an email anytime, but more than likely I'll be able to get right back to you during that time. All right? So contact me if you need anything. Hope everybody's feeling good. Talk to you guys later.